Hello students, Mr. Thompson here. This is one of my first video recordings and I'm not used to listening to my own voice on this, so I apologize if I sound strange. I probably don't sound strange to you, I just sound strange to me, but in any case, this is one of my first attempts at this podcasting, and hopefully it'll go well, and hopefully you'll continue to see some improvements throughout the semester. So here goes. Chapter 1, the Copernican Revolution. And Mars is going to play a very important role in the Copernican Revolution. Actually, doesn't have anything to do with a war in this case. It has only everything to do with a change in our way of thinking about the universe. So what do we have to look forward to in Chapter 1? Well, four main parts to this. The first being the motion of planets, motions of the planets, if you will. We'll go all the way back to Aristotle, who is an ancient Greek, and we'll work our way all the way up through Isaac Newton, who described our planetary motion very well. The second thing is the birth of modern astronomy. By modern, we really make a dividing line in about the 1600s, and that's what we're talking about with the Copernican Revolution. Thirdly, we're going to talk about the laws of planetary motion as delivered by a guy named Johannes Kepler. And then lastly, we'll talk about Newton's laws, which really furthered Kepler's laws toward development of planetary motion. So here we go. Here's a picture, a very famous picture of the Aristotelian universe. Notice that Earth is at the very center of all of this mess, surrounded by some words that look a little bit funny to us, but you can probably make them out. This looks like lunar, and sure enough, that's the moon. These are all Latin words. This looks like Mercury, Venus, Sol for sun, Martis, that's Mars. This is Jupiter, and here's Saturn. A couple of things to notice about this picture. One is everything moves in a perfect circle. The moon, Mercury, Venus, all the other planets, the sun, the stars, everything moves in a perfect circle around the Earth, and that becomes an important as we continue on in astronomy. Another thing, Saturn is the farthest planet from the Earth, and there's no Uranus. There's definitely no Pluto there. The Aristotelian universe only included planets up to Saturn. Why do you suppose that is? Well, this is before the invent of the telescope. Those planets simply had not been discovered yet, and those planets you can't see with the naked eye. So very good reason for that. Next, all of the stars lie in what we'll call the celestial sphere. Now, the celestial sphere really isn't there. It's not a sphere per se. But if you go out at night and look up at the sky, it looks like all of these stars are on the inside of a great big bowl, and that bowl is what we're calling the celestial sphere. That's what the ancients imagined. And then lastly, all of this appears to be moved by the prime mover. Notice these words up here, Primu, I don't know if I'm pronouncing this right, but Primu Mobile, that is for the prime mover. The ancient Greeks, or Aristotle, imagined that the prime mover was really the god of the universe that kept everything in motion. Something had to be moving these objects, and so he attributed that motion to the prime mover. Okay, so we've got to account for all of these bodies. One, the sun, two, the moon, three, the stars. They all have very simple movements in the sky. They're consistent with an Earth-centered system. In other words, there's no problem in putting the Earth at the center and having the sun and the moon and the stars all go around the Earth in about a 24-hour period. The planets, however, are very different. First, they move with respect to the fixed stars. If you watch a planet very closely, it's in a different part of the sky one night than it is the next night. Not so easily distinguishable night to night, but definitely week to week or month to month. You'll notice the planets are in different places. Here's a diagram that shows that. If you track the path of Mars, November 1st, December 1st, January, February, here's retrograde motion, and then back all the way through June. Notice that Mars moves with respect to the fixed stars. This top image shows a couple of things. Here's Mars, here's probably Saturn. And notice that both of them have changes in brightness as well. Also, they change speed. Sometimes they move a little bit faster, sometimes a little bit slower. There's this retrograde motion idea, which is very important. And they are difficult to describe in a Earth-centered or geocentric system. So how do we make a system that has planets move forward and backward at different times of the year? Well, a very basic geocentric model is as following. Uh, you put a planet on an epicycle. So instead of going around a perfect circle around the Earth, the planet is actually on the epicycle. It moves around the epicycle, and then the epicycle itself moves around what we'll call the deferent. So the deferent is the part that Aristotle got, and basically here's a new contribution. Well, what happens when we put all of the planets on this? Lots of epicycles were needed to accurately track planetary motions, especially retrograde motions. So this is Ptolemy's model. Ptolemy lived in about the 100s AD. So there was the Aristotelian system in 4th century BC, and now in 2nd century AD, about 500 years later, Ptolemy draws out this elaborate system. Here's the Earth at the very center. Notice the moon just moves around in a circular path, but then if you look at Mercury, it has an epicycle and a deferent. In other words, it has retrograde motion. Venus, and this shows kind of the path of Venus as it goes around the epicycle and around the deferent. Here's the retrograde motion part. The Sun is on a perfect circle, moving out from there. Mars has a very small epicycle and a larger deferent, but it explains its retrograde motion. And then Jupiter, and then Saturn. So the sizes of the circles are different, but I want you to notice everything on here still moves in a perfect circle, which is consistent with ancient Greek philosophy and really in some ways meshed in with ancient Greek religion. Now we move to a heliocentric model, of course with the Sun at the center. I want you to notice if we put the Sun at the center, all of a sudden that makes the Earth moving around the Sun. Not only is it moving around, it is actually spinning on its axis, which is a little bit troubling for philosophical views. Then here's Mars. How is retrograde motion explained with the heliocentric model? Well, if Earth is moving around faster and Mars is moving around slower, then you see that at some points Earth effectively laps Mars. It's like they're running on a track. I'll use track analogies as much as I possibly can. And Earth is going faster, and at some point Earth looks at Mars and it appears that Mars is going backwards. It's not that Mars really is going backwards, but Earth is going faster than Mars. So here's where Mars looks on the line of sight from Earth with respect to the fixed stars. For a while it's moving forward, and then after a while Earth is passing Mars, it looks like it's going backwards, and then off it goes again. So a very nice, concise model. You don't have to have epicycles, you don't have to have deferents, you just put the Sun at the center, and there you have it. Well, a guy by the name of Copernicus came around in the 1500s, and don't forget about how much time has passed here. Ptolemy was in the 100 AD era. Copernicus is alive in the 1500s, and his model isn't really accepted until the 1600s. And so going against nearly 1,000 years of philosophy, these perfect circles, these perfect shapes, a guy by the name of Nicholas Copernicus published his heliocentric model. And here's a picture of this model. And notice the Earth at the center has been placed with a glowing Sun. And then here's Mercury, and then Venus, and the Earth. Now the Moon is going around the Earth, which I guess it's always been going around the Earth, but one peculiarity with the Moon. And then we have Mars, Jupiter, and Saturn. We still have the sphere of fixed stars, but the reason that they appear to us every 24 hours is not that they're going around us, it's that we're spinning out from underneath them. New model. Here's another picture of the Copernican model. Some things I want you to think about. We're going to answer these in class. How did this new model go against Christianity? You see, Copernicus made the church very, very unhappy. Secondly, why then was the Catholic Church so upset? And then lastly, if you would have been alive during this time, how would you have reacted? In other words, you've got 2,000 years of history that says the Earth is at the center of the universe. Now somebody is saying the Earth is not at the center of the universe, it is indeed the Sun, Not only that, but the Earth is moving, and it must be moving very quickly. Of course, you can't feel this motion. It seems to us like the Earth is stationary. If you had been alive, how would you have reacted to this new information?